Hello, it's your favorite chemistry tutor once again, Farm Joe. Now we want to continue from where we stopped. We've started a series on SN1 and SN2, and I told you to understand that two reaction. You must understand first homolytic and heterolytic fission, then nucleophile and what electrophile. By the time we know this, then we can explain SN1 and SN2 easily. So we are done with the first series. On the first series, we looked at homolytic and heterolytic. Ensure you check that video before going to the second one and before going to the third one. Now for the second series, this series 2, now we are looking at nucleophile and electrophile. Nucleophile, they are electron rich. Electrophile, they are electron deficient. So I have points for them, and we are going to explain those points one by one, pick out some possible questions you can have there. Now, what are nucleophiles? What are electrophiles? Firstly, nucleophile. Nucleophiles, they are guys that love nucleus. Is that okay? Now, nucleophile, they love to accept, they love nucleus. And that is why nucleophile normally attack nucleus. They normally attack the nucleus of electron deficient guys. So, nucleophile and electrophile, from the word electro means these guys love accepting electron. Nucleophile, this guy loves attacking the nucleus. So in case that's where the two words is coming from. And why are we studying them? I told you SN1 means nucleophilic, so you must understand what a nucleophile is. Is that clear? So nucleophile, they are electron rich. For electrophile, they are electron deficient. Guys that are electron deficient, for example, NO2, this guy NO2 is electron deficient. Is that okay? Why guys like OH minus, guys like H2O, they are electron rich. They have electron to donate, electron to give. Is that clear? So next thing, nucleophile, because they have lone pair of electrons, they are ready to donate electron pair. Nucleophile normally donate their electron pair. They have it. They donate pair of electrons. Is that okay? Why? Because they have lone pairs. They have surplus electrons. They are electron rich. So because they are electron rich, they give. Why electrophile? What do? They accept that electron that was donated by the nucleophile. And that is why in a nutshell, we normally call nucleophile a Lewis base. Yes, this question came out for part 2 students. That which of this following is true about a nucleophile? Nucleophile are Lewis base. Why? Lewis base donates electron pair, while Lewis acid accept that electron pair. Is that okay? So they are known as Lewis base, while electrophile are known as what? Lewis acid. Why are they called Lewis acid? Lewis acid normally accept the electron pair that was donated. Now, how do we identify them again? We identify them by nucleophiles normally have negative charge. For example, Cl minus, OH minus, Cn minus, Cl Br minus. You can see all those guys with minus. They are nucleophile. Nucleophile are negatively charged. Why electrophile? They are positively charged. Guys like what? Guys like, let's say, Na plus, K plus, H plus. You can see all these guys, because they are positives, they are what? They are electrophiles. So guys, yes, guys like hydrogen plus, K plus, Na plus, hydrogen, especially hydrogen plus. So these guys are negatively charged, because we are dealing with organic chemistry. Most likely you'll be seeing H plus. Yeah, they are all electrophiles because they are positively charged. Next thing, so anytime you see a negatively charged atom, you say it is nucleophile. Positively charged, you say it is what? Electrophile. Now let's move to the next one. They have lone pair. They have what? Lone pair of electron. Why these ones? They don't have lone pair of electron. Nucleophile normally have lone pair of electron. Who can give me examples of compounds with lone pair? H2O. H2O has lone pair 2. Ammonia has lone pair. Do you remember now? 1. This guy has 2 lone pair. This guy has, so any guys that have lone pair can be referred to as nucleophile. Nucleophile normally have lone pair. You remember that your Lewis base also normally have a lone pair. That is why this guy can qualify as a Lewis base. Ammonia H2 also qualify as a Lewis base because of his lone pair. It can donate. Thank you. Now they have lone pair of electron. I think we've agreed to that. But as for electrophile, they do not have lone pair. In fact, electrophiles, they don't have lone pair, and they used to have neutral molecules. They are neutral molecules that have incomplete octets. For example, look at this guy, BF3. For BF3, this is 1, 2, 1, 2, 1, 2, 1, 2, 3, 4, 5, 6. This is having 6, and this is the way the guy looks like without the lone pair on it. You can see that there's no lone pair on it, and this guy is 1, 2, 3, 4, 5, 6, which is 6. Normally, what should be around this guy should be 8. Is exhibiting what we call incomplete octets. So most neutral molecules that normally have incomplete octets, they are referred to as what? Electrophile. Maybe I should give you another example. BeCl2. This guy is Be to Cl to Cl. This guy has 1, 2, 1, 2, no lone pair on it. And this is 1, 2, 3, 4, 4. And it is okay like that. You can see that this molecule is neutral. It is okay this way. And it is performing incomplete octet. This is also having incomplete octet. So every compound you notice with incomplete octets, is that okay? They are referred to as what? Electrophile. And I think another thing you should pay attention is anytime we see a pi electrons like C double bond C, one is sigma, one is pi. Our pi electrons are rich. They are rich electrons, free electrons that can be attached to. That is why any guy that have double bond or triple bond, or are you getting it? They are referred to as nucleophile. Why? Because nucleophile are electron rich. Now, for the purpose of what we want to do, SN1 and SN2. SN1 means nucleophilic substitution. Nucleophilic substitution. You are substituting with a nucleophile. SN2, nucleophilic substitution 2. We are also substituting with a nucleophile. So anything I'm bringing must be a nucleophile. So that is why I have to go through these routes to teach you SN1 and SN2. Then I've seen a question that I want us to pay attention to. Br minus is an example of nucleophile, but Br2 is not a nucleophile. In most cases, it will not be a nucleophile. Why? They can ask you, or we have Cl minus is a nucleophile, but Cl2 is not a nucleophile. Why? And why is this normally happening? The problem is if Br2 is coming, I told you that we are doing what we call nucleophilic to substitute with a nucleophile. If Br2 is coming to a guy that is electron rich, that means if Br2 is coming closer to a guy that is a nucleophile. Are you with me? The nucleophile, this guy that is electron rich, that have a lot of electron. Because this guy also has a lot of electron, this also has a lot of electron. When the electron of this guy sees the electron of this guy, it makes this Br2 to become polarized. Normally, Br2 is Br attached to Br, and they are negative and negative. They are neutral. Br2 is neutral, but by the time you move Br2 closer to a guy that have electron, much electron, it will make this Br2 to easily polarize. Polarize means you start having Br partial positive and Br partial what? Negative. What caused this? Because you move it closer to a guy that is a nucleophile already. Now, by the time you move a Br2 that has a lot of electron inside it, when you move it closer to a guy that is a nucleophile, it will cause this Br2 to become they are easily polarized. This guy too is still, so we have Br partial positive, Br partial negative. Initially, what we have is Br minus, but because this guy come in contact with a nucleophile that has more electron, he's seeing this guy that also have electron. It causes this guy to become, because if electron sees electron, it will repel. The repelling effect causes this guy to become easily polarized. We now have partial positive Br, partial negative, which started as negative, neutral. Something that was neutral is now having an electrostatic force such that we have positive side and negative. Is that okay? Now, this guy this one that is negative, and this one that is positive. This positive now, we start attacking our nucleophile, making this guy to start reacting as Br plus. So anytime, in nutshell, if you see Br2 and Br minus, Br minus is a nucleophile, but Br2 most likely do not act as a nucleophile but start acting as Br partial positive, which is Br2 normally act as electrophile. The same thing, Cl minus act as a nucleophile, while Cl2 most times act as what? Electrophile. And I've seen a question like this in your past questions. So if you have more question for me, you can type it there. So we've been able to differentiate between a nucleophile and electrophile. If you see any question, I'm going to send more questions to you. Maybe tag some questions on the screen so that you try those questions. I'll look for some questions, I'll put it on my screen, then you attempt it. Thank you so much on nucleophile and electrophile. Now let's now go to SN1, nucleophilic. We've learned about nucleophile, so we want to go to nucleophilic substitution, substituting with a nucleophile. So we have SN1, SN2. We also have E1, E2. E1, E2 have to do with electrophilic. Is that okay? So thank you so much. If you love this video, if you enjoyed this, ensure you subscribe, comment, and we are going to the next series, which is series 3. We are going to the series 3. Thank you so much.